So welcome to lecture 4. So in this lecture we'll talk about complex numbers. So in chapter 1 we discussed the number theory and we divided numbers into real and imaginary numbers. So we told that imaginary numbers are numbers that have a square root of a negative value. So square root of negative 1 has a peculiar property that it can be written as a number I. So the I represents the imaginary number. So the third theory was that you could write any negative square root of a number into I value. For example, if you write root minus 15, it can be written as root 15 into minus 1. So you can split it as root 15 into root minus 1. So this can be written as I root 15. So this was the idea behind imaginary numbers. So complex numbers are combination of both real and imaginary numbers. So think of them as the superset of real and imaginary numbers. So because they contain both real and imaginary numbers in them. So an imaginary number has a form of a plus bi. So a here represents the real part of the number and bi represents the imaginary part of the number. And the combination is called as a complex number. So an imagination of a complex number is to think of it like a Cartesian diagram of two axes. On one axis you have the real numbers, on the other axis you have the imaginary numbers. So this is the imaginary axis and this is the real axis. So on this axis you have all the real numbers and on this axis you have all the imaginary numbers. So if you want to write, for example, let's say this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, 5. Let's say I want to write a number 2 plus 3i. Then this number would be written in such a way where we go 2 in the real axis plus 2 in the real axis and we go 3i in the I axis, we go plus 3. So this point represents the number 2 plus 3i. So this is an example of how you can visualize complex numbers using as plotting them as points. So this is the idea behind complex numbers. So simplification of complex numbers is as simple as it is. So if you consider using the radical laws, we can consider any number. For example, if you have root negative 49, that becomes, you can write it as root 49 times negative 1 and you can write it as root 49 times root negative 1. So root 49 is 7, negative 1 is I. So you can replace root negative 49 with 7i. So this is how simplification of a number generally works. So now this brings us to the question of operations on. So the next topic is operations on complex numbers. So let's say we are trying to add two complex numbers, a plus bi and c plus di. So the addition works in such a way where we add the real part of the number separately, a plus c, plus, and the imaginary part of the number b plus di. And if you want to subtract, the same rule again. So a plus bi minus of c plus di can be written as a minus b plus c minus di. Sorry, a plus So a minus c plus b minus d I. So this is how you can perform operations on complex numbers. Let's take some examples. So let's say we have 3 minus 4i plus 2 plus 5i. So we only add the like terms and like terms or unlike terms separately. So the like terms are 3 and 2. So you write 3 plus 2 minus 4i plus 5i. So minus 4i plus 5i becomes I, and 3 plus 2 becomes 5. So 5 plus I. So this is how we can solve this problem. Let's take another example. Let's say we have minus 5 plus 7i minus of minus 11 plus 2i. So how would you solve this? First simplify and write it as the regular one. Minus 5 plus 7i. Next minus into minus becomes plus 11. Minus into plus minus 2i. So now add the like terms and unlike terms separately. So 11 minus 5 becomes 6 plus 7i minus 2i becomes 5i. So 6 plus 5i is the answer for this problem. So now you try an example. Let's say we have 2 plus 5i minus of 3 minus 4i and 5 plus 7i plus minus 12 plus 8i. So try these two problems. So pause the video right here and try to solve these problems. Let's go to the next one, which is multiplication. So how do you multiply complex numbers? So when you are just multiplying a complex number with a real number, for example, let's say we have 3 times 6 plus 2i, we can simply write it as a distributive law. So 3 times 6 and 3 times 2i. So 3 times 6 plus 3 times 2i. So 3 times 6 is 18 plus 3 times 2i is 6i. So this is as simple as it is. So when you have to multiply a complex number with a real number. So try another example. Let's say we have 4 times 2 plus 5i. Again the same thing, 4 times 2 plus 4 times 5i. So 4 times 2 is 8, 4 plus 4 times 5i is 20i. So try an example, half times 5 minus 2i. So try this one. So pause the video here and try to solve this problem. So let's try next one, which is multiplying a complex number with another complex number. So let's say we have an example of 4 plus 3i times 2 minus 5i. So because these are binomials, we can use the FOIL method. Remember FOIL method? So the first term, outer terms, inner terms, and the last terms. So the first terms are 4 and 2. So 4 times 2 plus, next outer terms are 4 and minus 5i plus 4 times minus 5i. Next plus, inner terms are 3i into 2, so 3i times 2. Next last terms are 3i and 5i. So plus 3i terms minus 5i. So 4 times 2 is 8. So 4 times 5. So remember distribution. So 4 times 5 is 20. So minus 20i. Next 3 times 2 is 6. So plus 6i. Plus next again 3 times 5 is minus 15. So we can write minus 15. I times I becomes I square. So remember the rule here. We know that I is root negative 1. I square becomes root negative 1 square. So which is square root cancel, you get negative 1. So I square is negative 1. So replace this with -1, you get 8. So simplify the value, 6 minus 20, that is minus 14i, minus 15 into I square is minus 1. So you get 8 minus 14i plus 15. So 15 plus 8 is 23 minus 49. So 23 minus 49. So this is the value of 4 plus 3i times 2 minus 5i. So let's try another example. You have 3 minus 4i times 2 plus 3i. So pause the video right here and try to solve this problem. Remember, the value of I square is minus 1. So use this I square value when you want to use it in the problem, and make sure all the signs are correct. So pause the video right here and try to solve this problem. So let's go to the next one, which is dividing complex numbers. So how do you divide one complex number with another? So let's take a simple example of, let's say we have a plus bi by c plus di. So the idea here of dividing is to make sure that the denominator stays real, right? So denominator is a real number. So what we do here when we divide here is that we rationalize the denominator. So when you divide complex numbers, we rationalize the denominator. So remember, rationalization is we need the factor that we need to multiply, which is the rationalizing factor. So rationalizing factor just says, just change the sign in the middle and you get the rationalizing factor. So for c plus di, the rationalizing factor is c minus di. So you multiply with c minus di by c minus di. Right, so we rationalize the denominator. So let's try an example. So let's say we have a number 3 plus 4i. The rationalizing factor of a complex number is called as the complex conjugate. So complex conjugate is a number that turns another by multiplication into a real number. So a number that can turn another number into real multiplication is called as the complex conjugate of a number. For example, 3 plus 4i, the conjugate is 3 minus 4i. So how would you know if it's real? Is multiply the two numbers, you get 3 square minus 4i square. So you have 3 square minus 16i square. So 9 minus 16 times -1. So 9 plus 16, that is 25. Notice that we have turned this number into a real number. So remember this formula, a plus bi into a minus bi is actually a square plus b square, not a square minus b square, but a square plus b square. So with that in, let's try division. So let's take an example. So let's say we have 2 plus 5i over 4 minus i. So we multiply and divide it with the complex conjugate. So the multiplied value is 4 plus i over 4 minus i. Sorry, 4 plus i by 4 plus i, not 4 minus i. 4 plus i. So now we have 2 plus 5i terms 4 plus i over, remember the formula, a plus bi times a minus bi is a square plus b square. A square is 4 square plus I square. So b square here is, remember that a plus bi. So when you want to write this, a minus b, a plus b into a minus b, you can write this into a plus b into a minus b as well. So here a is 4 and b is 1. So you get a 4 square plus 1 square. So that becomes 2 plus 5i times 4 plus I over 4 square plus 1 square is 16 plus 1. So 16 plus 1 is 17. Now try to multiply the top part. So first is 2 into 4 plus outer terms are 2 into I, 2i plus 5i into 4. So 5i into 4 plus 5i into I over 17. So 8 plus 2i plus 20i plus 5i square by 17. So 2i plus 20i is 22i plus 8 plus 5 times I square is minus 1 over 17. So 22i plus 8 minus 5 by 17. So that becomes 22i plus 3 by 17. So or we can split it and write it as 3 by 17 plus 22 by 17i. So this is the value for 2 plus 5i by 4 minus I. So this is the simplified version of the value, right? So what we are doing when we rationalize, we are converting two separate rational complex numbers into a single complex number, right? So let's try another example. So let's say we have 3 plus 2i by 2 plus I. So what do we do here? Multiply it with the conjugate of the denominator. The denominator is 2 plus I, the conjugate will be 2 minus I. So 2 minus I by 2 minus I. So that becomes again here A is 2, B is 1. So 3 plus 2i times 2 minus I divided by A square plus B square is 2 square plus 1 square. So if you don't remember the formula, so we know that A plus BI times A minus BI is A square plus B square. So when you want to know, so 3 times 2 is 6 plus outer terms are 3 times minus I is minus 3i. Next 2i times 2 is 4i. 2i times minus I is plus 2. So minus 2i square by 2 square plus 1 square is 5. So 4i minus 3i is 1i. So 6 plus I minus 2 into minus 1 by 5. So 6 plus I plus 2 by 5. So 8 plus I by 5, or you can split it and write it as 8 by 5 plus 1 by 5i. Right, so this is the value for 3 plus 2i by 2 plus I. So this is the value. So try another example. Try 2 plus 3i by 2 minus 3. So remember the rationalizing factor, we are looking for the denominator is 2 plus 3i. So multiply and divide with 2 plus 3i and find the final answer. So pause the video right here and try to solve this problem. So also try some more problems. You have 2 minus 3i by 4 plus 3i. You have 3 plus 4i by 2 minus I. So pause the video here and try to solve these problems and see if you can find the final answer. So with that, we end the lecture on complex numbers.